Now, sometimes you'll be asked to differentiate something first and then use what you've found to integrate something else. We've already seen how to integrate something like this, which is not a perfect question, but we know how to adjust it. So a question like this is actually even easier because we've got a great big clue. We're differentiating something and then adjusting that. So step one here, differentiating this, we need to differentiate what's up here in the index. And when I differentiate 3x squared, I get 6x, and I need to bring that down the front. So I'm going to get 6x e to the 3x squared. So I know that differentiating this gives me this. So if I integrate this one, I'll get this plus c. Now over here I need to find a definite interval, so I won't be adding c. Instead I'll be using my big square brackets here. Now I really would like to integrate this with the 6x out the front, and what they've given me is a little bit different, so I'm going to have to adjust for that. So let's set out our working here. We're wanting to find the integral of this. I'm going to rewrite my question as one that I'd rather do. I'd rather find the integral of 6x e to the 3x squared, because that's the one that I know how to do. But I've changed the question. They gave me 12x and I want to do 6x, so I can adjust for that by just putting a 2 out the front. Now I can go ahead and say I've got two lots of, I need my big square brackets here, and the thing that goes in is the integration of this stuff, which is this. So I put this in the brackets, and I put my bounds. Now I've got to keep this 2 out the front, and I've got to sub in 1 for x, and then subtract subbing in 0 for x. So I'm going to get e to the power of 3 lots of 1, that's 3, minus e to the power of 3 lots of 0, which is 0. So that's going to give me 2e cubed, and 2 lots of, well this part's 1, isn't it? So minus 2, and that's my answer.